Yeah, g'day, it's Charlie ZL2CTM. Well, I just want to do a quick video today just to provide an update on where I'm at and to have a look at the configuration of the switching that I've done for this, as well as, I guess, an update on the microphone amplifier and the bits. So anyway, the receiver side is all there up and running, and is working very well, which is great. In the end, I alluded to this in the last video, because the SI5351 here is covering up the Arduino, I can't see the on-board LED, which is a bit of a shame because it would have been quite useful to use that. So I've actually just pulled that out here, and you can see down here just a little high-intensity green LED, which will be good in broad daylight. You should be able to see that quite nicely. So just, again, we go through the mode. We're now transmitting an N, so dialed it. For the North Island mountain radio service. Then if I just push it again, it then defaults to the south, so S, and then I can go back to normal. So just a longish heartbeat for normal 3690 kilohertz for the QRP frequency. Let me just turn that, disconnect that power there, and I'll go through the configuration. Let me just disconnect this wiring here is just for test. So, the good thing is it's fitted reasonably well onto the board here. As you can see, I've sort of taken up just under 2/3 of the board. So I'll have another dividing plane up here between what will become the transmit side and the receive side. So I think I've got plenty of room here. Up in the corner I'll fit the antenna relay and the antenna connector. And then on the spine that separates the two will be the transmit receive switch. So anyway, just to sort of run through what it is, RF is coming in through this relay here, and I'll go through that configuration in a sec. Passes through the first IF amplifier, through the crystal filter, back through the second IF amplifier, back through that switching relay there. I don't know if that's clear on the video, I think it is. And then back into the product detector, which now is an ADE-1. Same with the mixer on this side, both ADE-1s now. Nice small size here, nice and compact. The output of that is now audio on reception, which then gets fed into up here, our audio amplifier using that LM380. So that's working out nicely. And then that's being fed down through that blue audio cable down to this connector here. So in line with a recommendation that came through on the first video, I have elected to use a pair of old headphones here. So these ones are, I think this is a knockoff pair for the Apple, and inside this little controller here is a microphone. And incidentally, it looks like there's actually no hole for the microphone, but the sound comes in through the cracks on the side, which is interesting. But as I'll show you later on, there's a little electret microphone in here. What I could gather online, it looks like the biasing's around 0.5 milliamp at 2.2 volts, which I've just used 2 volts at 0.5 milliamp, which we'll look at in a sec. Anyway, that comes back through a four-way switch, where we have microphone, ground, and then left and right, or the right or left, doesn't really matter, for the headphones, and that's why the connector down here is, which is good because in past builds I've had to have two connectors, one for the antenna, so again one for the microphone and one for the headphones, and this one here is quite nice and compact now. I get away with just having one, and I've got that coming out the front, which is nice. What else before I sort of go into the switching side of the house? 78 LO5 down here, so that's taking in our 12 volts and dropping that down to 5 volts for the Arduino and the SI5351, and there are really no other changes there. Just got a small piece of board just to provide a bit of isolation between the two sides of the IF strip, which I've used before and certainly works well, as is the case in this particular case. It works well too. Anyway, so I mentioned in a previous video that this switching network down here allows me to have the RF always going through one direction through the IF strip, so I don't have to have bidirectional amplifiers. I can just get away with the same amplifier configuration for both transmit and receive. So if I was just to pull it away and then bring up this here, so Hopefully this is not too difficult to read, but at the moment the two black relays you can see down here, let me just go back and point those out again. That's these two black ones here. They are double pole, double throw relays, which are indicated here and here. So one double pole, double throw relay is dedicated to the first mixer, and the second one dedicated to the second mixer. So at the moment the contacts here are in the receive configuration. So as you can see here, RF is coming in, going into the RF port of that first mixer. It's being mixed with the VFO. I've underlined that because that is the configuration, or the default, or more the point, yeah, the configuration for receive is probably the best way of saying it. Then the output of that mixer is our IF, going through that second half of that double pole, double throw, through our IF strip, through the bandpass filter, back down, and then into our second relay, through that contact, into the RF port of our product detector. Its LO port is the BFO frequency, hence the underline here. The output, of course, on the IF port is audio frequencies, which goes through the audio amplifier and out to the speaker, or the headphones in this particular case. Now, on transmit, these connections here go down to the bottom set. So we start on the left hand side here. We have our microphone amplifier here. It's feeding in audio into what was the IF port, and this becomes our balanced modulator. In order to output an IF frequency, we now need to feed in through the LO port, not the VFO frequency, which will be the carrier oscillator on transmit, but we want to feed in the BFO frequency. So in software, I have, if I was to nip back here again, you can't quite see it unfortunately, but below these two red wires here is a voltage divider with two resistors, which I think I've included in the schematics online, and that basically senses the 12 volts on transmit and outputs a 5 volts, which is then read by the Arduino to know what state it's in, either transmit or receive. So once it knows what state it is, for example in this particular case we're now on to transmit, what was clock 0, so that one there, that now becomes on receive, that would have been our VFO, that now becomes our BFO, and output on clock 2, which on receive is our BFO, will now become our VFO. So that's what I'm meaning here. So just to recap then, on transmit, our microphone audio comes in through the IF port on our balanced modulator now. Let me just drop that down a bit. We have our BFO frequency coming in, output is the IF, which is now going down here, and because of this little link, it now sends the IF over to here. It can't go any further this way because this contact's now moved down here, so there's no problems with, we've got isolation. And then back through the IF strip, out to this side. Can't go anywhere here because that switch is now in this position here, so it's blocked off. So it goes through this little link and pops in through here. That's now down here, up through there, and into our mixer through the IF. That's then mixed with, it now toggles across to here to our VFO frequency, so it's acting as our carrier oscillator. And then that gets mixed up to our desired RF frequency, which then goes down this way through an RF amplifier, through the antenna switch and out the antenna. So this has worked very well for me in the past, and because I can have down here a nice isolation wall, I don't have any kind of crossing over of RF, and I've eliminated a whole lot of problems I had with earlier radios with feedback. Where I had one relay that was basically sort of switching across to here, back through here, then back across to this side, and because of these contacts here within the relay are very close, in those other configurations I was getting a little bit of RF that was getting back through the input, and like I say, I was getting feedback. But this particular configuration here totally eliminates that, and you get very good isolation between the outers and the inputs, or the outputs and the inputs. So anyway, so that was, I think it was a question about that on the last video, so I just wanted to draw that up. I mentioned the microphone amplifier. That's the first part of getting this to turn into a transmitter. I do the microphone amplifier first because what I can then do, because of all the switching networks all wired up, I can basically have coming out of this port here very quickly a very low level of modulated RF at the desired output frequency, which then I can detect on a receiver just to make sure that the modulation side of the house is working before starting to build the RF amplifier. So the microphone amplifier here, nothing special at all. Again, just using, because I've got a whole stack of them, a 2N3904 and a common emitter configuration with voltage divider biasing there. Just using a little 10 ohm decoupling resistor there in the VCC line coming down. So I've configured this to be an ICQ or a quiescent current of 10 milliamps. I mentioned in the previous video that I don't operate for that long out in the field, so having 10 milliamps is just fine. Off the spec sheet, my beta DC for 10 milliamps is going to be a range of 100 to 300, so I'll take the geometric mean and come out with 173. As we've seen in previous configurations I've used for this one here, I'm just setting my voltage at the emitter to be 1/10 of the VCC, so 12 volts divided by 10 divided by my quiescent current through the device comes out at 120 ohms. I won't go through all of these because they're all up online and no real difference from what I've done in the past. I'll just basically say that to have that nice stiff biasing up here, I've got 10 times the base current flowing through this one. Because I use electron flow, we've got current coming through here and up here. That makes 11 times the base current flowing through here, which we've seen reflected down here in that value for our two resistors, R1 and R2. I'll just say there I've set the collective voltage to be halfway between 0 and 12 volts, which gives me oodles of enough swing there to modulate this radio, and then that's just being dropped onto a 10k ohm trim pot, which will allow me then to get the level about right so I'm not overdriving things. But having that set at half VCC is more than enough. So if that's the case, then my collector resistor, just for completeness, I've decided to work out what the voltage drop is across that 10 ohm resistor. It's not very much at all, but hey, you know, for completeness. So therefore a half of 12 volts is my VCC, minus that very small voltage drop, comes out to be approximately 6 volts, funny old thing. And therefore 6 volts divided by that 10 milliamps is 600 ohms, so I'm going to use a 560 ohm resistor. Now for the coupling capacitors, I've let the capacitive reactance of this decoupling, or say again this bypass capacitor for RE, I'll set that to be 1/10 of the RE value, so RE divided by 10 at the lowest frequency of operation, which I've assumed to be 300 Hertz. So that's what we have down here. So RE divided by 10 at 300 Hertz is for capacitive reactance. We know that capacitive reactance is 1 over 2 pi FC, so we can basically rearrange that formula there to make our capacitance the subject. So we just put that up there and that down there. Plug in the numbers, comes out at 44.2 microfarads, so I'm just going to use 47 microfarads. Remember, as my capacitance goes up, my capacitive reactance goes down, which makes this even more true, so that's the right way of going, or the right direction of going. Now, in terms of the coupling capacitors coming in, that's the capacitors on the base and on the output. So this one here and this one here. I've just set to be an arbitrary less than 100 ohms, so I don't get so much of a losses at 300 Hertz. So exactly the same approach. Rearrange the formula, plug in the values, comes out at 5.3 microfarads. So I'm just going to use 10 microfarads, which is nice and easy in the box. Could have probably got away with quite happily 4.7, but what the heck, I've got lots of 10, and it makes this even more true, so why not? Now the last important resistor in this particular amplifier here is what I've called RM, the resistor for the microphone. this is an electret which requires a bias voltage. So what I've done here is from what I could, as I just mentioned before, it looks to be around 2.2 volts at half a milliamp roughly, bias for that. I didn't find anything definitive, so I've gone with what I have used in the past, which is just that. I've dropped that down to 2 volts at half a milliamp biasing, which like I say has worked well. So if that's the case, then I need to work out what the voltage drop is across that resistor, and then divide that by half a milliamp to come up with the actual resistance itself. So 12 volts is on the top side of that resistor. I'm going to subtract again, just for completeness, the small voltage drop across that 10 ohm decoupling capacitor in the VCC line, and then that answer there, minus 2 volts, gives me the voltage drop across the resistor. So Ohm's law divided by half a milliamp comes out at 19.8 k ohms. So I'm going to use a 20 k ohm resistor, and that's exactly what I used for that particular bias. And like I say, on the oscilloscope and actually feeding the output of that microphone straight into the audio amplifier just for test purposes, it sounded nice and crisp and clear. There was certainly a difference when I brought the microphone up to my mouth and I had it in this orientation versus this orientation. So we'll see how that works actually in the field, but I suspect I may end up just holding it gently and just bringing it up close to the mouth with the slot facing the mouth. But either way, it's a nice tidy configuration to have both the headphones and the microphone on the one cable, so I'm quite happy to run with that. So next steps now will be to start working on the power amplifier. I'm happy with the receiver, I'm happy with the microphone amplifier, that's working well. I'm happy with the switching network, that's all working well now. So it's just a matter of just quietly putting up that next, or the barrier, or that next, the barrier, let's call it that, between the receiver and the transmitter, and then just quietly thinking about where I want to have that double pole, double throw switch, of which I'll just go and grab one. So I'll use one of these for the transmit receive. I'm only using 5 watts, so it'll be fine. And in fact, I'm not actually passing any RF through here, because what I'll elect to do is have sitting over here next to the antenna connector a small relay which will do the actual the RF switching. This will just switch to 12 volts, which will trigger the transmit voltage down here. What I've got down here is just a small, and I apologise, there's no real structure to this conversation, it's just more me sort of rambling away. It's got a very small little strip down here with 3 segments, 12 volts, which is only on for receive, a transmit 12 volts, and then this little portion down here is fixed 12 volts, that's always on. So it'll just transmit, it'll just sense the relay will sense the transmit 12 volts, switch over, and then transfer that antenna from the receiver to the transmitter. So that's what I'll sort of quietly work on in the next week or so. Got a few other things I need to do, so I think the pace might slow down a bit, but it's all heading in the right direction, which is good. Okay, I think I've rambled on long enough. Again, apologies for the sort of unstructured nature of this. And again, I've mentioned this many times, I am absolutely no expert in any way, shape or form in RF design and in radio construction and the like. This is very much just a video log of what I've been playing around with, and I guess what my thinking is and what my approach is. It works for me. I'm more than happy with using these little plastic lunch boxes, or storage boxes. They work just fine for what I'm after, and like this whole hobby of ours with amateur radio, it's each their own. It's what makes you happy and the enjoyment you get, and that's it. So hopefully through these videos I can sort of impart, I guess, some of my thinking, which might help others to give homebrew a go as well. Because as you can see here, there's nothing overly complex here at all really. Most of all the smarts here it's all already done for you. It's just the software engineering. and the design of these amplifiers are very straightforward. I keep things very simple, and that's what I enjoy. Anyway, I have well and truly rambled here, so I will say 73s, stay safe, and we'll see you next time. Cheers all.